Hello students and friends. So today we will discuss the problems on the topics which we discussed in the previous two video lessons. So what we have learnt in the previous video lessons is we have derived two formulae to find out the number of solutions, right? So for example, first one what we have derived is the number of non-negative just I'll repeat those two rules which we have discussed in the earlier videos. The number of non-negative integral solutions of the equation x1 plus x2 plus x3 plus up to so on xr is equals to n is what is that number? How many non-negative integral solutions exist for this linear equation in which you have the right hand side number n and the number of variables is r is what? N plus r minus 1 c r minus 1. This is the first rule we have seen this, and the second rule, instead of the number of non-negative integral solutions, number of positive integral solutions. For the same equation, how many positive integral solutions are there? What is the rule we have? N minus 1 c r minus 1. So for the same equation, if you want number of positive integral solutions, we have the formula n minus 1 c r minus 1, and if you want only non-negative integral solutions, that is x1 plus x2 plus up to so on xr is equal to n equation, the answer is n plus r minus 1 c r minus 1. This is nothing but the number of ways of distributing n identical objects into r distinct boxes, so that no restriction, without any restriction, right? So without any restriction, if you want to distribute n identical object into r boxes, the direct result you can use n plus r minus 1 cr minus 1. Whenever no box empty means at least one object should be there in the box, then n minus 1 cr minus 1. Okay, so this is these are the two properties, these are the two rules we have seen in the previous two lessons, right? Now here we are going to apply how to apply these rules into different situations. Okay, so we will solve 3 to 4 problems in this class today. Now here the first problem is we have to find out the number of integral solutions of this equation satisfying some condition. Can you see the equation? What is the equation given to us? X plus y plus z plus w is equals to 20 for this equation, right? Say equation number 1. For this equation, you have to find out integral solutions. He did not mention whether it is a non-negative integral solutions or positive integral solution, but it is mentioned clearly that x is greater than or equal to 1 and y is greater than or equal to 2 and z is greater than or equal to 3 and w is greater than or equal to 4. So satisfying these conditions, x is greater than or equal to 1, y is greater to 2 and z is greater than or equal to 3 and w is greater than or equal to 4. How many solutions are there for this equation? Okay, now what we are going to do, we are going to convert this equation into the situation 1 or 2. Which one we are going to do is first one. Okay, now what I am going to do, you see here, because of x is greater than or equal to 1, from this what you can say, x minus 1 is greater than or equal to 0, means x minus 1 is non-negative, right? Similarly, y is greater than or equal to 2 means y minus 2 is greater than or equal to 0, means y minus 2 is non-negative. So z is greater than or equal to 3 implies z minus 3 greater than or equal to 0. W is greater than or equal to 4 implies w minus 4 is greater than or equal to 0. So therefore, this x minus 1, y minus 2, z minus 3, w minus 4. Now these four values are what? Non-negative. These four values are non-negative. Is it clear? So now whenever you have non-negative variables in your equation, you have a direct formula to find out non-negative integral solution. What is that? N plus r minus 1 c r minus 1. Here n is right hand side number, r is number of variables or number of boxes. Now what I am going to do, I am going to change this equation in which we will see this x minus 1, y minus 2, z minus 3 and w minus 4. How can you make it? So from x what you do, you subtract 1. From y what you do, you subtract 2. Again from z you subtract 3 and again from w you subtract 4. So you have subtracted how much? 1, 2, 3, 3, 6, 4, 10. So that 10 we subtract from the right hand side. Now instead of x minus 1, for some time I will say it is capital X, and for y minus 2 I will say it is a capital Y, and for z minus 3 I will say it is capital Z, and this is capital W, which is equal to 10. Now you got a different equation. Okay, little bit conversion is done here. The same equation is converted into the another form, where this capital X, capital Y, capital Z, capital W, you can see this is I suppose as capital X, this one I suppose as capital Y, and this Z minus 3 we suppose as capital Z, and this is capital W. But you can see here x is greater than or equal to 0, yes, y is greater than or equal to 0, and z is greater than or equal to 0, and w is also greater than or equal to 0. So what are the variables you are seeing in the equation? Capital X, capital Y, capital Z, capital W, these all are non-negative. So indirectly what you are going to find is the number of integral solutions of 1, satisfying these conditions, x greater than or equal to 1, y greater than or equal to 2, z greater than or equal to 3, w greater than or equal to 4, is same as the number of solutions, the number of non-negative integral solutions, I can say. Why I can say? Because of we made it like that. X greater than or equal to 0, y greater than or equal to 0, z greater than or equal to 0, w greater than or equal to 0. So we want the number of non-negative integral solutions of the equation which is converted. This one, say this is number 2. So number of non-negative integral solutions of 2 you have to find out. Okay. So this is equals to what? Number of non-negative integral solution formula is n plus r minus 1 c r minus 1. In this, n is number of identical objects. This is number of identical objects, you can say. Okay, or it is a right side number in your equation. So in the equation, what is the right side number here? 10. Okay, so n value is 10. And what is r? Number of different boxes. R, number of variables involved in the equation. How many variables involved in the equation? X, y, z, w. 4 variables. So r value is 4 and n value is how much? 10. So the answer is 10 plus 4 minus 1 C4 minus 1, which is 13C3. Yes or no? Now if you want, you can calculate this 13C3. 10 plus 4, 14 minus 1, 13C3. So you can calculate if you want 13 into, what is that? 12 into 11 by 3 into 2 into 1, 6. So 6, 2 is 12. So 13 into 22. If we calculate this, 13 2s are 260 plus 26, which is 286. So 13 into 22, which is 286, you can see, which is there in the A option. Okay. So this is the way of applying the rules what we learnt in the previous 2 lessons, number of non-negative integral solutions and number of positive integral solutions. So here in this question, he is not asking number of non-negative integral solutions. Something given, x is greater than or equal to 1, y is greater than or equal to 2, z is greater than or equal to 3, w is greater than or equal to 4. But using here x minus 1 and y minus 2 and z minus 3 and w minus 4, we converted the given equation so that the variables are non-negative, right? So that we can use the first property. Now let's see one more question. Now this is question from 2013, online April 22, based on the same concept. Now we can check this. The number of ways in which an examiner can assign 30 marks to 8 questions, right, giving not less than 2 marks to any question. So total number of questions, how many total number of questions we have? 8. And how many marks we have to assign to these 8 questions? So in total we have to assign 30 marks to these 8 questions, right? But you should not give less than 2 marks to each question. So here we have question number 1, question number 2, question number 3, question number 4, right? So like question number 5 and question number 6 and question number 7 and question number 8. So totally you have 8 questions. We have to assign some marks to Q1 and some marks to Q2 and then some marks to Q3. Like for example, you can assign 3 marks to the question 1, 2 marks to the question 2. For example, you can give some 3 marks to question 3. Like this, you have to assign marks to each question randomly, right? But what is the condition? Each and every question must be assigned, must be given at least 2 marks. 2 marks or more than 2 marks. You cannot give 1 mark or 0 marks to a question, right? Minimum marks should be given to each question is 2 marks. But after giving that marks, if you add all those marks, q1 plus q2 plus q3 plus q4 plus q5 plus up to so on q8 should be how much? 30 marks. Yes or no? So here you got an equation in which you have 8 variables, and each qi, what is that? Each qi is greater than or equal to 2. What is the meaning of this? Whatever the marks we have given to the first question, it should be greater than or equal to 2. Whatever the marks you are allotting to the second question, it should be greater than or equal to 2. Like that, each and every question, for each and every question, the minimum number of marks is 2. So therefore, qi is greater than or equal to 2. What does it mean? q1 is greater than or equal to 2, q2 is greater than or equal to 2, q3 is greater than or equal to 2. Likewise, each qi is greater than or equal to 2 implies, what you can do here, qi minus 2 is greater than or equal to 0. Yes or no? Qi minus 2 is greater than. What does it mean? What does it mean? Q1 minus 2 is greater than or equal to 0. And also Q2 minus 2 is greater than or equal to 0. Q3 minus 2 is greater than or equal to 0. So this is true for all I is equal to 1 to 8. So Q1 minus 2 is non-negative. Q2 minus 2 is non-negative, Q3 minus 2 is non-negative. So you can use that non-negative concept from the previous problem, right? So what I am going to do, can you guess? I am going to subtract 2 from Q1. Similarly, I am going to subtract 2 from Q2 and 2 from Q3. So I will continue this up to Q8, okay? From Q8 also I am going to subtract 2. So totally how many 2's we subtracted from the left hand side? 2 8's are 16. So you have to subtract that 16 from the right hand side also. So now I will suppose this Q1 minus 2 as capital Q1. Let's say, okay, is it good? Capital Q1, or this is capital Q2 and capital Q3 plus up to so on capital Q8, which we have 14. Now here each qi is greater than or equal to 0, means each and every number in this equation, variable in this equation, is non-negative. So what you have to find out here? You have to find out the number of non-negative. You have to find out the number of non-negative integral solutions. Number of non-negative integral solutions of this equation. Of the equation just now we have obtained. So what is the formula for number of non-negative integral solution? Once again I repeat, n plus r minus 1 c r minus 1. What is n here? N is identical objects. How many identical objects are there? Or RHS number. What is the number you are seeing in the RHS of the equation? And what is r? R is number of boxes. You can say number of boxes, or if you see in the equation, number of unknowns or number of variables. Okay, now we can see here n value, number in the right hand side is 14. So here n is equals to 14. And what is r value? Number of variables or number of boxes. How many boxes? Q1, Q2, Q3 up to so on Q8. So r is equal to 8. Apply the formula. 14 plus 8 minus 1 c 8 minus 1, which is 14 plus 8 is how much? 22. Yes or no? 14 plus 8 is 22 minus 1, 21, and that is C9. So 21 C, sorry, a small mistake. 8 minus 1 is 7. So 21 C1. You can see 21 C7, sorry, 21 C7 you can see in the C option. Okay. So this question you can see a practical question given to you, but we converted this into the equation, right? So you can use these linear equations whenever such type of questions given to you. Right. Let's see one more question so that you will understand better. Now here you see, if n objects are arranged in a row, then number of ways of selecting 3 of the objects so that no 2 of them are next to each other. No 2 of them are next to each other. So how many objects are arranged in a row? N objects. Let's say here you have an object x1. You have an object x2, you have another object x3, x4. Like this you have n objects arranged in a row. Now from this you have to select how many objects? We have to select we have to select 3 objects. Any 3 objects you have to select. But these 3 objects, no 2 of them are next to each other. So means, for example, if I take x2 object, the next object is not x3, because of, he says that condition, no 2 of them are next to each other. So after selecting x2, you cannot select x3. If you want, you can select x4, or if you want, you can select x5, or if you want, you can select x6, but not x3. Right? What is the meaning of this? In between any two selections, there must be one object between them. At least one object should be there between them. Okay? Then only they are not next to each other. Okay? I hope you understood this. What is that? In between two selections, in between two objects, there must be at least one object should be there. And after the second, whenever you select the third one, at least one object should be there again in between second and third. Okay? At least one object. Right. So this is actually the idea behind the problem. Let's say I selected one object here, second object I selected somewhere, and third object I selected somewhere. Now, how many objects are there between, before the first object, whatever we selected, the first one, before that how many objects are there? Let's say that is something y1. Okay, number of objects. What is this y1 represent? Number of object before the object selected, the first object selected. Okay, next y2 is number of objects between the first object and second object, and y3 the number of objects between second object and third object. Okay, after selecting the 3 objects, I am supposing that before one, for example, if you selected x3, how many objects are before x3? 2 objects, that is your y1. So here y1 is equal to 2. For example, I am telling you. Okay, and in between first and second, how many objects are there? I am supposing y2. In between second and third, how many objects are there? I am supposing y3. After the third object, whatever the object left with us, we'll suppose as y4. Okay, then can you tell me what is y1 plus y2 plus y3 plus y4 is going to be? y1 plus y2 plus y3 plus y4 value going to be what? Can you tell me that? Because of, see, how many objects in a row you selected? 3 objects. So other than 3 objects, everything is counted in this. Yes or no? Before first object, how many are there? In between first and second, how many there? How many objects are there? In between second and third object, how many are there? After third, how many objects are there? So how many objects you are leaving in your counting? These 3 objects you are leaving. Remaining all objects are counted. So total number of objects are n. In your counting, only 3 objects are missing, which we selected. So n minus 3. So y1 plus y2 plus y3 plus y4 should be equal to n minus 3. Okay. Now, in between first object and second object, at least one object should be there. Otherwise, they will become consecutive, right? They will become next to each other objects. So there is at least one object in between first and second. So in between first and second, what is the number we supposed? y2. So y2 should be at least 1, means y2 greater than or equal to 1. Similarly, in between second and third also, there should be at least what? One object should be there. In between second and third object, at least one object should be there. What is that? y3. So y3 should be greater than or equal to 1. And what about y1 and y2? There are no conditions on y1 and y4. So y1 should be greater than or equal to 0. y4 should be greater than or equal to 0. But if you want to apply the rule that non-negative or positive integral solutions, whatever we derived 2 formulae, non-negative, right, non-negative nature. Here y1 is already non-negative, there is no problem with this. y4 is already non-negative, but you can see here y2 is not non-negative, it is 1 or more than 1. So what I will do? y2 minus 1 is greater than or equal to 0, and here y3 minus 1 is greater than or equal to 0. So we are going to convert this y2 and y3 from the equation. So y1 plus y2, I will write y2 minus 1, and y3 I will write y3 minus 1, and this is y4 is equal to, because of you subtracted 2 from the left hand side, you have to subtract 2 from the right hand side also. So n minus 3 minus 2, which is n minus 5. Now what we are going to do now, y1, this y2 minus 1 I will suppose as capital Y2, and this y3 minus 1 I will suppose as capital Y3 plus y4 is equals to n minus 5. Now you tell me here what happened. Y1, which is greater than or equal to 0, capital Y2 is also greater than or equal to 0, capital Y3 is also greater than or equal to 0, Y4 is also greater than or equal to 0. So each and every variable in this equation is non-negative. So therefore we want to find the number of non-negative, again non-negative integral solutions. We want to find a number of non-negative integral solution. What is the formula? Once again I will write n plus r minus 1 c r minus 1. N is the right hand side number, r is number of variables. So right hand side number is n minus 5 plus r. R means what? R minus 1 means what? Number of variables minus 1. Number of variables how many? 4. So 4 minus 1, which is 3 c 3, which is going to be n minus 5 plus 3, which is n minus 2 c 3. Okay. So you can see that n minus 2 c3 is there in the first option. A option is n minus 2 c3.